Good morning. As promised, here is a video to help with the homework assignment that is due on Sunday. It's the last homework assignment from section 2.2. Excuse me. The assignment was 89 to 102. All I'm going to do the odd ones for you here, which should help you do the even ones. Reminder that there's a test on Wednesday on 2.1 and 2.2. I will post a practice test today on Friday. And then Monday, I will post both the answer key to that and probably a shorter second version of a practice test, just to make sure you guys can be as prepared as possible for the test on Wednesday. So here we go. The first three problems ask you to find the average rate of change of a function on an interval. And you have to know that that's just asking for the slope. Gives me a couple endpoints, find the y values, do y2 minus y1 over x2 minus x1, average rate of change. That's not calculus. Calculus is the instantaneous rate of change, which would be the derivative of a function, but we don't want that right here. So in order to do this function on this interval from 1 to 2, you know that I need to do f of 2 minus f of 1 over 2 minus 1. Now I just got to be careful doing some arithmetic here. This is 3 times 2 plus 5 minus 3 times 1 plus 5 all over 1, really, because that's 2 minus 1. And that is 6 plus 5 is 11 minus 3 plus 5 is 8 over 1. Turns out to be 3. The average rate of change is 3. Now, for that problem, one could argue that was a silly question to ask, because look at the function. It's f of t equals 3t plus 5. That's just a line, whose slope is always 3. So it should make sense that on any interval, the average rate of change of a line is going to be whatever the slope of the line is. So that was kind of baby steps as we get into these. Next one, the function is negative 1 over x from the interval from 1 to 2. I don't know if you know what this looks like. You maybe should know what this looks like. Negative 1 over x looks like this and like this, I believe. So somewhere here is the point of the interval. There's 1 something, and there's 2 something. So I'm finding the slope of a secant line. Not drawn very well, but that's what I'm finding. So this is still f of 2 minus f of 1 over 2 minus 1, which is negative 1 over 2 minus negative 1 over 1 all over 1. Got to be careful with all those negative signs. That's negative 1/2 plus 1 over 1. That's just 1/2. Average rate of change from 1 to 2 is 1/2. Slope of that line would be 1/2. All right, one more. Now I've got the function x squared plus e to the x. No idea what this looks like. But find the average rate of change from 0 to 1 is going to be f of 1. There went my camera, sorry. F of 1 minus f of 0. Sorry about that. Minus f of 0 over 1 minus 0. So as the f of 1 would be x. Nope, that's a lie. F of 1 would be 1 squared plus e to the 1 minus 0 squared plus e to the 0 all over 1 minus 0. Let's see, 1 squared is 1 plus e is just, that's 1 plus e, and then minus 0 squared is 0, and e to the 0th is 1 over 1. I think that just becomes e. Remember, that's a number like 2.7 something. So average rate of change. Be on the lookout for average rate of change. That's not a calculus issue. All right, the next two problems have to do with vertical motion. 95 and 96 give you this formula, and you've just got to recognize that negative 16 t squared means that we're talking in feet per second and feet per second squared, not meters. So I didn't type out the problem, but it says a coin drops. If I drop the coin, you have to know that that means I'm not throwing it down with any initial velocity. I am dropping it. That means my initial velocity would be 0. You have to recognize that from that word, just dropping something, as opposed to throwing something up or down. Coin drops from the top of a 1362-foot tall building. So that's telling me the initial height, 1362. So you have to have interpreted that from the problem. Part A says determine S of t and V of t. Well, S of t is just plugging in these numbers to the equation that I gave. This is negative 16t squared plus 0t, because the initial velocity is 0, and plus 1362. I would probably clean that up and not have that 0 term in the middle. So just plus 1362. There's my position function. And then it also wanted v of t, which is the velocity function, which you have to know is the derivative of the position function. That's s prime of t. So that's just the derivative of this, which is, let's see, move the 2 out front. 2 times negative 16 is negative 32. That'd just be t to the first. The derivative of plus 1362 is in fact 0. So I think there's your answers for part A. I've got the position function and the velocity function. All right, part B says find the average velocity. Now you got to be real careful here. Average velocity is the rate of change of the position. So average velocity is just where am I now, where am I then, and subtracting. So I think I said this in the notes, but it needs to clarify. It is a very common mistake. The average velocity is not on the this one says the interval from 1 to 2. It is s of 2 minus s of 1 over 2 minus 1. Not v of 2 minus v of 1. That would be the rate of change of the velocity, which would actually be the acceleration, which we'll talk about before long in this chapter, but not here. So you just have to recognize in context the average velocity on an interval is the change in position over change in time. So you have to now. I'm gonna cheat a little bit. You just have to plug in 2 and plug in. So I did the math. I'm gonna let you actually do the arithmetic, but negative 16 times 2 squared plus 1362 turns out to be. No, I lost it. S of 2. Oh, there it is. Sorry about this. Oh, there it is. So this turns out to be, actually, I do have the pieces here. Sorry about that. Negative 16 times 2, where am I? Times 2 squared plus 1362. That is S of 2. And then minus negative 16 times 1 squared plus 1362 all over just 1. And that becomes negative 64. Where'd it go? 64 plus 1362. And then turned out to be plus 16 and minus 1362, distributing a minus sign. Turns out to be all over 1, which turns out to be negative 48. And that would be feet per second. That is the rate of change, the average velocity, which is the rate of change of the position. Average velocity. Okay, that was part B. Part C asks for the instantaneous velocity when t equals 1 and t equals 2. So that's asking two things. It's saying find v of 1 and then find v of 2, the instantaneous velocity. That's just evaluating the velocity function. So my velocity function was what? Negative, where's it? Negative 32t. So v of 1 would just be negative 32 times 1, which is negative 32. This is velocity, so it is feet per second. And then v of 2 is negative 32 times 2, which I believe is negative 64 feet per second. All right, that was C. And then part D says, find the time, and it asks, part D asks two things. It says, find the time required for the coin to reach ground level and the velocity of the coin at impact. I didn't just lose that. Okay, good. All right, so part D says, find the time for the coin to reach the ground. When the coin reaches the ground, its height, its position equals 0. If the position represents how high off the ground it is. So I'll just say this. So you have added in your notes. At impact, S of t equals 0. That doesn't mean S of 0. I'm not plugging in 0 for t. That would be my position at time 0. That's 1362. I want to know at what time the position equals 0. So it becomes negative 16t squared plus 1362 equals 0. Now you're solving that for t, like at what value of t? So I have 1362 equals 16t squared, and I have t squared equals whatever this divides out to be, and then I square root it. Now, when I square root this, officially I get plus or minus something. Turns out to be 9.23. In context, a time of negative 2.3 seconds doesn't make any sense. So it takes 9.23 seconds for it to reach the ground. Then the question also asks, what is its velocity at impact? And that does not mean like when it hits the ground, its velocity becomes 0 because it went splat. It wants to know how fast it's going at the moment of impact. So now we just have to find V of 9.23, which is just negative 32 times 9.23, which turns out to equal negative 295 feet per second. So there is question 95. Number 97 is very similar, except it uses the meters per second generic equation, which is just a negative 4.9. Other than that, it's very similar. So 97 says a projectile is shot upward from the surface of Earth with an initial velocity of 120 meters per second. Initial velocity of 120 meters per second, shot up in the air. If it were shot downward, the velocity would be negative, but shot upward. And it says from Earth's surface, like from the surface, that tells me the initial position is in fact 0. So then you have to be able to interpret that from the picture. Now you'll notice the question just asked, what's its velocity after 5 seconds and 10 seconds? So it really says find V of 5 and V of 10. You, of course, need to know that before I can do that, I actually need to find the velocity function, which is the derivative of the position function. So let's rewrite the position function with the right numbers. It is negative 4.9t squared plus 120t, and I'm just going to put a plus. I'm not going to put a plus 0, but it is a plus 0 there because there is no initial height, which makes my velocity the derivative of that, which is 2 times negative 4.9 is negative 9.8t, and then plus 120. There's my velocity function. Now, this question wanted V of 5 and V of 10. So V of 5 is negative 9.8 times 5 plus 120, which turns out to be 71 meters per second. That's how fast the thing is going after 5 seconds. It's positive, so it's still going upward at that point. And then V of 10 would be negative 9.8 times 10 plus 120, which I think turns out to be 22 meters per second. Still hasn't stopped going. It's going up more slowly. In a couple seconds more, it would stop, and then it would start going down. The velocity would be negative. So I think that's all 97 wanted. All right, the last two questions are the first time we've seen, and it's an important concept to talk about, and we'll see it more later this chapter and the next chapter, is if I know what the graph of a function looks like, what might the graph of the derivative looks like? These two problems, 99 gives you a position function, asks you to sketch a velocity function, and then 101 is backwards. It gives you a picture of the velocity function and it asks you to sketch the position function. So let's look at 99. All right, so there is the position function, time, distance, and I labeled the order pairs they gave you. It wants us to sketch the velocity function. Well, you have to know that the velocity is the derivative of the position, and the derivative represents slope. So whatever the slope of the position function is, that's the actual y value of the derivative. Let me say that again. When you're going from a graph of f to a graph of f prime, or in this case, a graph of s of t to a graph of v of t, whatever the slope is on the original graph will be the actual y value, because the y value of the derivative represents the slope of the original graph. So here I have 3 line segments. We need to find the slopes of those 3 lines. So let's label these. Here's line A, here's line B, here's line C. The slope of A, slope is just y2 minus y1 over x2 minus x1. So that would be, that's supposed to be a colon there, A, like that, like that. Whatever, there it is. So the slope here is 2 minus 0 over, that's a minus sign, over 4 minus 0. That's just 1/2. That's the slope of that line. The slope of line B, it's a horizontal line, that segment. The slope of line B is 0. The slope of line C would be, let's see, I'm doing, oh, that's a typo. Sorry, it should say 10 comma 6, not 10 comma 2. Sorry about that, 10 comma 6. So my slope would be 6 minus 2 over what, 10 minus 6, which is 4 over 4, which is 1. That position function has a slope of 1/2 for a while, and a slope of 0 for a while, and a slope of 1 for a while. Well, you've got to know that that means that whatever the slope of the function is, that's the y value of the derivative. So I'm going to label some points here. I'm going to just get the out of the way for the moment. Let's go back here. And so I just need 4 and 6. And so that's 4, and that's 6, and over here is 10. So on the interval from 0 to 4, the slope is 1/2 for that entire interval. That means the y value of the velocity is going to be 1/2 for that entire interval. I'm going to draw a line like this, label it 1/2. Like there's my velocity function. My velocity is constant. That should make sense because the position function is changing at a constant rate. The slope is a constant 1/2, so the velocity is a constant 1/2. What about from 4 to 6? From 4 to 6, my position, my distance, oh, there goes my camera again, sorry. From 4 to 6, my position doesn't change at all. The slope of that position line is 0. So that means that my velocity is, in fact, 0. So that's going to be right here. So from 4 to 6, my velocity is 0. I want that to fit with the slope of that line segment B. And then from 6 to 10, the slope of the line segment is 1. And the slope of the position is the y value of the velocity. So from 6 to 10, that was 1/2, go up here, label this 1. It's going to look like that. Should have made the function different color. So there and there and there. There's my velocity function. But you need to know that those velocities represent the slopes of the position function. So that was number 99. 101 does the same thing backwards. It gives you, look at my picture in the way again. It gives you the velocity function. It wants to know the position function. So now you've got to know that the velocity, that gives you the slope of the position function. So since this, again, let's label this A and B and C. Since line A has a value of 40, the velocity is 40, that means the slope of the position would have to equal 40. So now I'm going to draw a line. I'm going to erase this in a second, but I'm going to draw a line segment here from 0 to 6, and it's going to have a slope of 40. Now I got to be honest with you. I could draw this. I could draw this. I could draw, like, we don't exactly know where it starts. We don't have enough information. I might just start at the origin to be simpler. And I might make it an actual line. But I am going to maybe make this, I don't know, we'll pick Halloween. So I'm going to go like this. Oh boy, what am I doing? First, I'm going to undo all that. That was not good. So I'm going to go like that. Oh, I did 2 again. So, all right. So I'm just going to go like that. I just got to label this so that the slope is what I want it to be. Let me get rid of this line. Sorry, in trying to draw nice lines, it got ugly. So the slope of that has to be 40. So I can do some math in my head here. I think if I label this 240, that slope would be, so that point right there is the slope 6 comma 240. And if I do that from the origin, 240 over 0, 6 minus 0, I do in fact 240 divided by 6, which is 40. So the slope of that line is 40. What about line segment B and the velocity is 0? If the velocity is 0, that means the slope of the position is 0. So now I'm back to here, and now I'm just going like this. And this would then be, nope, I want to go there. And that would be 8. So since the slope of that position function is 0, that means the y value of my velocity, which it gave me in that thick red line, is 0. And then what about from 8 to 10? The velocity function tells me that the velocity between 8 and 10 is 60 meters per second, or feet per second, whatever the unit is. That means the slope of my position has to be 60. So I don't draw very well, certainly. I'm going to draw a point here like this, but it should be steeper than the last one because the slope of 60 is steeper than the slope of 40. So I'll put a 10 here. Now let's label some points. That point right there, if the first point was 6, 240, that point would be 8, 240. This point is the point 10, something. I need my slope to be 60. And I see that I'm doing some math in my head here. I don't want to. My slope would be something minus 240 over 10 minus 8. Like I need that to be, what was it, 60? So that's, let's see, 10 minus 8 is 2. I know that 120 divided by 2 is 60. So if I put a 360 right there, I get 120 over 2. So that turns out to be 0.10, 360. So just your first example of sketching a derivative from a function and then vice versa, sketching a function from a derivative. We'll do more of that as we learn more about derivatives. So I think that's it for your explanation of the odd problems on this homework, which is due on Sunday. Again, you're always welcome to email me questions. I really do want to help. Last reminder, test Wednesday and practice test will be posted shortly. Okay, have a great Friday.